Hey guys, hello and welcome to a new case. This time enter the matrix, a community case, and it's hard. And my solve will be lambda free, so bear with me. It might take longer than half the hour, but I like my approach anyways, although I have to say it's not the most efficient one. Do I want to explain something? No, you will see it. Here, simple text split based on the column delimiter X lookup, and here returning our letters, and then concat. Basic and simple. Don't know why this. Yeah. Okay. And then you have two pieces. You have the pieces, and you need to look up how which letters you can build out of it. And you should list the letters in alphabetical order, which letters you can build with the glyphs. So in this case, I've copied the glyphs here. They're really nearly unreadable. And then len of this minus len substitute, so to see how many of those glyphs are in there. Yeah. Okay, and then we have the number of the coding glyphs in there. And then I can simply do filter for the letter if by row this is smaller or larger or equal, larger or equal than this. And then bj, no, something is odd. Glyphs have to be smaller or equal. Yeah, smaller or equal. Sorry guys. Makes sense. I don't think I have where none is matching. That would be otherwise an issue with this filter approach. Then the signals come joined together, and you have to split this somehow. And so the issue is, or was, so you have here length of 3. You take here 3 characters, and then which is then your next starting point, and therefore text split. Let s minus text split s. So here we have the numbers. This is the number of characters, and now we want to have the start points. So I scan with 1, then I use those numbers and make the sum. But now I have to do the following: haystack 1 drop here the last column, and then I can use a mid of this. This is the start number, and the length is s, and then I can do my X lookup concat combination. I look up for the glyphs in the pulse code, returning the letters, and everything is concatenated. Machine, yeah, I should have copied it further, but seems only to be valid words, or words at least. And yeah, we can then do the following. So 2 letters are stuck together, 1 hidden boundary, so we don't know where it is, the separator. And we now need to know the first letter, the size of the first letter in glyphs, and the second letter. And I did this by the following: I concatenated. To call this and to row the same, and then the same for the for the letters. There's a space in between, yeah. And then I simply only need to look up XLOOKUP for the signal. In here, returning here those glyphs, and now I first have to use left one equals len XLOOKUP n in here. No, letters returning the pulse code, so that order. And then equals right one. And I can then copy this down and simply concatenate first letter and length of the first letter and second letter. Here we go. Now it is getting tricky because of the following. You have here a lot of stuff, and this here is more than 4 characters. And let's think of the following. We are combining those characters and we have combinations. Let's say we want to brute force this. Then we have 26 combinations times 26 for 2 letters times 26 for 3 letters times 26 for 4 letters, and at least at the 5th letter we will go out of the bounds of the rows. So therefore something here is especially important, which I overread in my initial attempt. There's no ambiguity in the glyphs. So yes, you might be able to brute force this, not in Excel, but you don't need to brute force this. And I will show you an approach, the approach of how I did it, where you don't need to brute force it. Yeah. Okay, so what I did first was take the length of the glyphs. How many glyphs are maximum in one character? 7. This is an information I need later. Let's copy it in here, 7. So, and then I use the reduced approach. This is my initial value. And then I used sequence, len of all of this. Doesn't matter, we will fix this later. And now we're getting lambda a, b. You know, I love using a and b. vstack a. Now it is getting important. I open this let statement. Let I. Now I take, because you will see it later, it is hard to explain. So I'm dropping out everything I've done before, and I'm taking the from everything before. So from A, I'm taking the last row and the first column. And then I use S, which is then mid. Now I'm using I, so what I've taken out. My start number is 1 and number is sequence and 7 rows, because I know, okay, at maximum there's 7 glyphs, and I'm taking in the whole signal, which is then used. Then I search if this is a character. So XLOOKUP S, and since I'm mid sequence, so I first row is like 1 character, second row 2 characters or glyphs. XLOOKUP S in here in the pulse code, returning the letter. Now back to the, yes, I know that not everything is closed. If not found, let's take the error. And then I do the following. I'm doing, because this will then either, I showed this. So equals mid, this one sequence 7, yes, equals XLOOKUP on this in here, returning our letter. So here this is then turning our n. And what I'm now doing, I'm searching for the position of the n to drop those number of characters from my continuous string and then give out the letter. So xlookup is giving me the, so now match xmatch true in not is number x. This is then how much to drop, and then I use hstack and I stack to call of x ignoring errors with no, this is in the second column. In the first column I'm using I have my string, which is I'm using right of I len of I minus m. Yes. Close everything. Calculation error, great. Sequence lambda b a mid I start number 1 s is this here, should be fine. X match not s num is number is error, still error. So this should not be an error, and I filter this out. Okay, I think if error, then give me nothing. Okay, yeah, this has fixed this. I now have always the trailing remaining number of characters in here, or the glyphs that are remaining, and on the other side the letters. I have now here a weird issue. I've not figured out why, but I will simply reduce this by xmatch nothing in take our first column, and then take from our that many rows and this second column, and then to call 3 and concat. I know it is way more complicated, and also let's make this here in hard-coded reference. It sounds way more complicated than it is, but using this reduce approach is doable if you don't know RegEx, and I still haven't catched up with RegEx, even though there's a great course by Hayden. But time is time. So the second level will be easier. So because I'm using one of my lambdas, so cell ref based on reference and error array, not using intermediate steps, but first I need errors. Row list clockwise. Cell ref not using intermediate steps. This is my reference sequence. 8 plus 1 starting from 0, and I'm using always going down error. No, what have I done? Oh. Okay, F2 sequence. No, F4, not F5. Then sheet name is matrix rain. So this is then giving me the addresses, and here with indirect turning on, it's giving me the glyphs. Now, there are also so-called noise glyphs in there, and to filter out the noise glyphs, I'm using xlookup and these are only the valid glyphs. Xlookup, C in the valid glyphs, and return only if it's a valid glyph, otherwise return nothing. This is giving me then the real number of glyphs. V and then concat cc concat the real number of glyphs. I have a call this v. I don't know. And then I'm using here this lambda from above, or this let statement from above, which I name w for word, put up in cc. W is then returning the word, in this case neo, and w and rows filter if v equals nothing, because number of noise glyphs is also important. I hope there are no 0 noise glyphs in there, otherwise I have a problem. Yeah, it does not seem to be, there's no 1 in there. Okay, level 6. Now level 7. Level 7 sounds super complicated, but actually isn't complicated. There's some weird time thing going on, and therefore I first split column number from cell reference and row number from cell reference. Row number is important. CR. And now, so based on the time, they're dropping like 3 cells all the time. And so it is then, and there's a wrapper. The wrapper is, because here are 67 rows, is it row 67? So write this in here. One of our constants. And then, so we're starting at 28. Or we're ending at 28. And therefore we have to go back 3 times 20, which is negative, I know. And now we're using mod -1, divisor is 67 plus 1, and we're getting to 35, which is correct. Make the divisor a constant and copy all of this down, which is us giving then the starting row, so to say. And then you also need to remember that if you're going then down, no, not destroying it. If you're going down, you can also start again here. So basically you're taking 67 maximum in there, or the size in there, but you can also start at the top. And I therefore do the following: mod this plus sequence. The question is always if this is then 22 glyphs or not. No, it's not. So it's 22 plus 1, because it wasn't before, starting at 0. -1, 67 plus 1. This is then giving me the rows. You see here, this is not touching the border and coming out at the top, but might be with others. This is our row, this is our column. Sheet text is matrix. I know I can also do this with my easy indirect. And then easy indirect is basically a map, and you can also put in here sheet names, because indirect will not work with erase. Matrix rain is then giving here the glyphs, and yeah, is this word and row? Okay, row is given, so I basically only have to use this here, which is not reusing the glyphs. So let I concat xlookup I in here, returning this. If not found, return nothing. Yes, and here I have done my word, and I then use my level 5 thing to return the word. And OS3 returning 22. No, that's not what is searched. This is searched, and it's Trinity. And row. Okay, and then use generate lambda statement from OA robot. Cool usage for something like this because I've modeled it out, but I don't need to model everything. Not that many steps, but yeah, and I then can basically put it in here. It has automatically, but check it, seen that this is a constant because I fixed this, and then I can basically drag this down and have all the levels solved. Took me shorter than expected, but bonus 5 will be hard. How many times does this glyph appear in total? And it's basically sum of this row here, this column here. How many of the 22 postcodes contain all 3 glyphs at least once? This is sum, or no, make this easier. By row larger than 0, and then it's sum minus minus, and it's 10. So glyphs 10. Which of the 22 letters have palindrome postcodes? And return the letters. I have a palindrome lambda called equals is palindrome. So palindrome is reading back and forwards and forwards the claim at the same. No, it is not working with arrays. Or is it? No. Good to know. Maybe I have to adjust this. And then it's basically equals concat filter the letter if this is true, because then it's a palindrome. Yes, and that's right. So in the matrix range tab, in which column is the glyph, however, the most frequent post glyph? In case of a tie, the column does not count. Answer with concatenating the letters of those columns in normal Excel order. So here we are. And what I'm now doing is most of char in area, but we can also do value. It's working the same. And then I get here a table with counting the glyphs and everything. Oh, this is issue. Only real glyphs. So actually only if this is a glyph, otherwise it's noise. If not found, return nothing. Here we go. And here I now have to see, okay, here in this case it would be this here. And I also have to account for the tie. So I do the following, let e. Now I search if index e first row second column equals index e fifth row second column, then nothing. Otherwise index e for 1. And then I also, if there is only a single valid thing, then if error return index E41. Yes. Make it faster. Now I still have one error in there, but the issue with that one is there's no valid glyph in there, so basically there's something in. The sequence columns, column letter from number, also lambda, easy. I don't have to explain what this does. It's creating the column letter from my number. So 27 is AA and 28 AB and so on. Which was the glyph? It was the first one. Filter this if this equals this, and then concat all of those. Matrix array. Great. No, bonus 5. It's hard. I can say this. So what I'm first doing is flattening the map. Flatten map. Flatten the matrix array. So I have here the values, the address, the row, the column. And I'm now doing the following. I'm, let's say, removing the invalid glyphs. So let's look up this in here, returning this here, otherwise return nothing. So I now have only the glyphs in there. And you know, we have here the column, and we're going in columns because we're only going down. And I'm therefore using here a group by. My row fields is my column and my value is my glyph, and I then concat everything. And I then have all the turn out this totals, no one needs them. And I then have here for all 72 columns what valid glyphs are in there. And what we can also do is add here, because the return, we want to search how many times white and rabbit is appearing in the matrix, and both the number of appearances as well as the number of glyphs, including noise, that you need to make those words. And here, if len of this is larger than 0, then return the row number, otherwise return nothing. Here it is then giving out the row number, and I'm now using here concat and haystack concat and array to text to return here for each column the concatenated glyphs, the real glyphs, as well as the appearance number. So now we I A T E R A B B A T equals concat x lookup, and here returning the false code. And adjust this. So now we have white and rabbit. White and rabbit in here, and we can simply say, okay, search for white and rabbit in this concatenated mess. And we can see here, oh, here somewhere is white, here somewhere is white, here somewhere is rabbit, and so on and so on. and therefore is number by row is number or filter both of this. In this case it's the word, but we already know, so basically this was unnecessary. I only need the rated text concatenated. And the appearance. And the first appearance. And we this is a messy no. I need the first appearance in all of this mess. I don't want to do this manually, but yeah, I know, Aki, I know. And then use this here. So we have the appearance. The word does not matter. We know that it's 5 appearances, and this is the start character, the start real glyph, and I have here all real glyphs and their numbers. And I know how long those words are. And filter this if this is true. And then we know that the last glyph for the coding word is this plus this -1. Yeah. So in this case, the 13th glyph. So starting at 37, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 57. Yeah, and I could do this manually, which would be faster, but we're not doing this manually. So text after equals text after this text. I first have to remove all unnecessary stuff. Text split this out, and unfortunately I have to filter this as filter as if s is unequal to nothing. Great. If len of s larger than 1, yeah, and then text join this. So here we go. Now we have only the valid glyph positions without noise semicolons. Text after in this text, these are our delimiters -1. No, this is the limiter, this is the instance number -1. And here we then have our glyphs, our starting glyphs, and text before. This is our delimiter, and our instance number is the length. Or is it? +1. Yes. And here we have an error. I have to figure this out, I assume, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because it is using here up everything. So if not found, and here in this case it will spill. If not found, if for text before is spilling, for Excel it's not. and then make a to call, ignore our all errors, and then text after the last semicolon, instance number -1, text before the first semicolon, and then this minus this plus 1. No, there's something odd. Something is not right because I know this is too high. It's starting at the second, so 12 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, I don't need this +1. Sorry. And now it's 88. Okay. That was my issue. And then equal sign. No, here B5. And underscore and sum of this. And it's solved. Okay, 36 minutes better than expected. I think because I also explained a bit. Would I be able to do this in 30 minutes in a live attempt? Never. Also because I struggled here, and then after the solve figured out, okay, I could do this with reduce and like using the accumulator. But yeah, anyways, it was a super fun and interesting case, an interesting approach. And yeah, looking forward to new cool cases. Thank you for your time. See you next time. Bye.